I had this little project I've been working on, and the intent of this project was to help me become a little bit better at programming microcontrollers. But every time I show it to somebody, they suggest that maybe I should put the project together as a kit for other do-it-yourselfers that have the same interest. What I have is a 3x3 aluminum cube. Inside I have 9 programmable LEDs on each face, and then I also have inside a charging circuit, an orientation board, a speaker, a microphone, and I believe that's it. Oh, a couple buttons. 2 buttons that I can use to program different things. I'm going to go ahead and turn it on. And as you can see right now, nothing happened. But this one's Bluetooth and it's connected to my phone, and I'm using the Adafruit app right now. You can see it came up on my thing. I go ahead and connect, and now it's on. So I have 6 different colors showing up on the different faces, similar to a Rubik's Cube, and I actually did program to turn each face and all the arrays that, the math that went into each one of these arrays, and how it, the algorithm for a Rubik's Cube, which was actually quite interesting, and I had a little bit of fun with that program. I'll go ahead and connect up to the controller, standard controller that you would use to program a robot, but I rearranged the buttons, I pre-programmed the buttons. This right now just turned everything red. I can turn everything green. Go ahead, I'll turn it blue. And I can go right back to what it was. So here, I'm just connected up Bluetooth, and I'm using the buttons to learn a little bit about programming and the interfacing of Bluetooth. This right here is just a rainbow pattern that's happening, and I can change the feather inside of here, so I could change it to a Wi-Fi, and I could actually write my own little app on the phone and connect up to it that way, or connect up to my computer. I've gone through some iterations of prototyping. Originally I had round holes. I didn't really like the round holes and ended up changing them to square holes. I went through different lens ideas and ended up deciding that the best thing that seems to work is just printing vinyl out. Here's the little lens. Printing it out on a Cricut, and they seem to fit right inside the little machined area that I have, and it seems to work just fine. I anodized it red. I anodized it blue. I kind of like the red better, and when the white lens gets on here, it's going to really give this some character. So I'll make another video, I suppose, that shows when this one is assembled. I also went through the prototyping of all the boards. These were some of the original boards that I put the lights on. I just etched these boards. I drew on them real quick, and then I etched them, and I soldered a bunch of lights in place. That led me to designing some other boards. I went ahead and designed the circuit that I was actually looking to complete. So I got my feather, I got an orientation board, I got the power circuit. We'll push this one on. The battery's charged. There it goes. The lights are coming up. So this one's working. There are some buttons inside. And right now what's not shown is I did this recently, take it off for a different project. There's a microphone on here. There's also a little mini buzzer that goes in here to make some sounds. That led me to prototype these boards. There's actually a video on my website that you could see of me machining these boards, and these boards were what I used to test out the project a little bit further before I went ahead and had boards printed. So here's the 6 boards that were printed. And then again, I went ahead and soldered on all the NeoPixel lights. Let's see, that would be this side. There's each one of the little lights that go on there. And then all the resistors and capacitors, the orientation board, the little microphone, the little speaker, and everything required to put this all together. I have another one over here. This one shows you what the inside actually looks like. I'll go ahead and turn this one on. There's the power button. And this one is come up as the 6 different colors. Actually, there you go. That one is changing the faces of the Rubik's Cube. It's rotating each one of these faces, and it'll rotate so far, keep all of its memory, and then it's going to turn them all back as if it's solving the cube. It wasn't so much that the cube itself can rotate or do anything. It was just interesting to be able to program all the algorithms to figure out the method to actually solve the cube. I'll go ahead and take this one apart and show you what's inside of it. Let's get back to, this would be my power button again, so I'm going to turn that off. And these plates are actually screwed down. There's 4 little holes in the top of here, and there's 4 holes in that plate. So the plate is actually screwed down. Each one of these is screwed down to a plate. I'll take this one apart too and show you how that is. So this is not how it is. It's actually each one screwed to a plate. But I'm going to go ahead and take this apart. And the way that it goes together, there's my battery. So this plate has the charging circuit on it, the on-off button and the charging circuit. As a matter of fact, if I push the button, you can see there it is, it came on. Push the button again, and there it went off. These have male headers, and then the opposing board all has female headers. A little hard to see, but those are female headers. So every board goes together with male and female headers so that they're all stuck together, which eliminates all the wiring. The only wiring that's really inside are these 2 wires, which are my D plus and D minus that come from the USB to get to the feather, because the feather itself doesn't actually have a breakout for D plus and D minus. But the power and everything else can be broken out of the board, and the feather just plugs in. So let's go ahead and take that board off. And it just presses out as well with the, there we go. Now disassemble these, and as you can see, I can take my USB connector then out. So here's my USB. The power goes into here and is broken out into the board, but the D plus and D minus I actually have to send to the USB of the feather. The feather unplugs. Therefore, it makes it interchangeable, and this board has a few components as well, resistors and capacitors, and then of course all the male and female headers that go into it. I don't know if you can see that a little bit better. There's some female headers on this board, male headers on this board, and that would be, again, the way all of these go together. So they're connected just by male and female headers. These boards, this one would be my orientation board. It's got some headers on here. The orientation board is off on this one, but it would be plugged in right there, just the way the feather plugged in. This board here has my little buzzer. This has my microphone. So I've programmed this to dance around to some lights. I've programmed it to listen to the sound and react to the sound. I programmed it to make a few sounds. I programmed this to do a Rubik's Cube. I programmed this to play tic-tac-toe. I can program the orientation, so whichever side I put up, it knows what side is up. And lots of other things that I've been learning to program on here. So this has been a really good kit, because once I put it together, I really don't have to take it apart. I can just continually to plug into my USB, program something new, experiment, and try it out. This one, I left the screws out of this board right here so that I could go ahead and take it apart as well and show you. So let me just power this off. And I'm going to slip this out. And this goes together a little bit nicer when the board lines up, because I don't have to line up the male and female headers. They just automatically line right up. So I can take this apart. There again is my battery. Inside I have the same thing. This one happens to be the Bluetooth feather. This one does have the orientation board on it. And there you have it. It's a kit that I can put together. I can program all kinds of different things, learn about microcontrollers, change out the microcontrollers to do other things with different microcontrollers. And again, every time I show this to somebody, they suggest that I should see if the do-it-yourself community has an interest in this being a kit. I'll go ahead and turn that back on. I have to go back over and connect back up again. There we connect up, and there it is, it's on. So give me a thumbs up, like this video if you think this should be turned into a kit. Give me some comments down below, share this video with others, follow my page if you want so you can see other videos like this, and leave me some comments so I know what you're thinking. You can also reach me at info@rettus.com. I appreciate you tuning in. Thanks for you. And I will get some more videos out there.